Alright, now I'm just going to touch on a few types of problems that we're going to see. The first one being one-dimensional, so 1D problems. You're either going to have horizontal or vertical. Stylus writing is a little challenging here. Okay, so for horizontal type problems, it can be simple like object on the surface. It can be pulled, with some applied force this way and maybe some resistance force this way. A nice simple sum of all forces equals MA type of problem. The only thing they can do to make this challenging is to include kinematics, where you will either have to use kinematics to solve for A first, or after you solve for the acceleration from the problem, solve for something else using kinematics equations. Okay. The other way they can do this is to give you some weird type of graph here. Of course, if they give you a velocity as a function of time graph, what can we get from a velocity as a function of time graph? Well, the slope here is the acceleration. So by using a velocity time graph, plugging it back into here, we can get a sense of what's happening more with the forces in the problem. Vertical problems, like lifting an object up, always have gravity as a factor. Usually with the one-dimensional ones, we're not worried about the normal force or gravity, because in this chapter we are not dealing with solving like coefficients of friction or anything like that. So we won't need the fun equation. If you remember the fun equation, F equals mu times the normal force. Okay, that's not until next chapter, so we don't need that. So with vertical problems, you'll have some type of applied force, and this is where I mentioned for the second law in the last video that when you sum them up, oops, not there, the direction of the unbalanced force, this net force, is going to be the direction of the acceleration. So if the object is being lifted upwards, the upward force has to be greater than the force of gravity. If an object is being lowered, so like you take your book bag and you go to place it down on the ground, you're not throwing it down on the ground, you're actually lifting it up. So there's an upward applied force. But which one's larger? Gravity is going to be larger. And that's why the object is going to accelerate downwards towards the ground. Right? So the acceleration for this situation is negative. The acceleration for this one is positive. It's in the direction of the net force, whatever force is bigger. We'll have two-dimensional forces, which just means you can have an object hanging from a ceiling from multiple strings. Maybe it's like a corner of a wall here. So we can have multiple cords holding on to an object, all right, so that there are tension forces along those strings. Again, a tension force is just the force that's along the cord, and it always acts along the cord, whatever it's going to be. Okay, so you'll just have angles, and you have to use your trig functions in order to solve this type of problem. You can also have an object on a surface, but then have the applied force being pulled up at some angle. Okay. Here is if we start going into the two-dimensional, directional forces, then we will have to take into account that type of normal force and any resistance force that there might be. Okay. Now, this normal force is almost never equal to mg. So what are the situations where Fn equals mg, or what are the parameters? Let's see. Okay, so weight and normal force, when are they equal? So the normal force and weight are only equal when the forces are balanced and there's no acceleration. Okay, when they are the only two forces in the up and down direction. If there is another force that has a y component to it, the normal force cannot be equal to the weight. Plus, it has to be on a level surface. So it has to be all three of these in order for that normal force to equal the weight. All right, so literally a block sitting on a surface, no other up and down forces. If we have an object in an elevator and the elevator is going up or down, guy's on an elevator waiting and he's moving, maybe he's going up, okay? There has to be more force upwards on him. If we're looking at him, there's going to be a force upwards on him, and that force is going to be the floor. There's going to be a force downwards on him, and that's going to be the force of gravity. These do not equal each other since the object is accelerating upwards. I did use the word moving. That was incorrect. For this situation, it's saying that it's accelerating. Okay? Now, I guess if it does say there's no acceleration and an object is on an like a person is on an elevator and it's going up or down, no matter what, if it says constant speed, okay, which goes along with this no acceleration, if it says it's constant speed, then the normal force and the mg are going to be equal to each other. So that meets all these criteria. No acceleration, there's only those two forces, and it's on a level surface. Okay. When we solve two-dimensional problems, you have to write out your sum of all force equations for both the x direction and the y direction. Very much like projectile motion. If you shortcut this, you are doing yourself a disservice. If you do not write these simple expressions right here, there's a possibility you can lose points. For almost every AP problem that is force-based, writing this down is at least +1 point. If you have no idea how to do the problem, at least write this and you'll get 1 point, probably in each direction. Okay? Very important. Start it out stating what you're going to do. You're going to add all the forces up in the x, continue all your work. Add them all up in the y, continue all your work. If there is a net force in a single direction, make sure that you combine the x components and the y components in the appropriate vector addition way. Pythag tangent. But also make sure that when you are solving a two-dimensional problem, yeah, you're starting with these ideas, but always ask yourself, is the object accelerating in the x direction? Is it accelerating in the y direction? So in a situation like this, where a block is being dragged along a surface, yeah, there's an upward component to the applied force. Yeah, there's an upward normal force to it, but most of the time they don't lift these blocks off the surface. So it's staying at this, position up and down the entire time. Here, this AY would be a big 0. Okay, so the sum of all forces in the y would be 0. And you'd only have a net force maybe in the x if it's accelerating.